Hi, let's discuss about edge devices, how they are used in railways to enhance operations and safety. Basically, right, in the current world, we have some disadvantages related to the operations and safety. So for that, right, there are some edge devices which are going to be developed, and some are already developed, which will enhance the features. So let's discuss about the challenges. So first one is the real-time data processing. Traditional systems, right, they some of the sensors, right, will not be able to get the data in real time, and there is a delays, right, in decision response times. So the other thing is operational efficiency. Even the maintenance costs and downtime due to unexpected equipment fail routes, right, will also affect the sync. So in this case, what happens is we'll not know when the equipment will fail. So once you have some solutions for this, right? So the number of the time for the downtime can be decreased. Then the safety concerns. So so you can increase the safety concerns are less, so you can increase the safety of the passengers, right? And you can have real time monitoring is also can be critical. In some cases it will be critical. Then the data bandwidth. So limited bandwidth for transferring large amount of data. So once we have to send some images, right, to every country, a lot of bandwidth will be used. So for that, right, there is some edge computing deployment which will be done, right, to counter all these disadvantages. So for first thing is that you need to have a edge device. So edge device you can integrate onto the network, railway network. So for that you'll have some sensors and IoT devices, right, which will be fetching the data and it will be sending to the edge gateways. So in between this sensor and the IoT devices, right, there will be some edge devices. Basically, right, the IoT devices are enhanced with edge features. So once we redevelop the IoT devices into edge devices, they are called as edge devices. So they can interact with the gateways to the gateways. Then you have the real-time analytics. So onboard analytics, right, like braking system analysis, engine form, performance, right, can be analyzed. So every time, right, the it will be monitored with the help of these devices. Trackside analytics can be done. So like for example, if you consider the trackside analytics, see in some cases what happens is their tracks will be removed, or some objects will be there on the tracks, right? So those will not be identified in the current day situation. Once you have some sensors on the tracks, right, those sensor data will be transported, right, to the IoT edge devices, right, with the help of a I2C or SPI bus. Then it will be communicated to the gateway. So in that way, here it will be useful. Then predictive maintenance. So in case of predictive maintenance, so condition based monitoring can be done for predictive maintenance. Like for example, performance and health, right, can be monitored before you get the failure, right? Like for example, in case of brake failure, right, suppose the oil level is going below the threshold, right, that can be monitored and sent to the gateway. So effective actions can be taken by the particular network. So maintenance alerts, like automated alerts, right, can be given here. So these are enhanced safety message, real-time analytics regarding some incidents, right, or anomalies can be done here. Video surveillance can be done. Edge devices, right, with integrated cameras can do the video surveillance. And passenger experience. So experience, like for example, some of the features, right, which can be enhanced. edge computing, right? With real-time data analysis, right? Like speed, high speed aspects for the Wi-Fi network, right? Can be given to the passengers. Because in a train, right, you cannot provide a Wi-Fi network without having any edge device. So this is the network diagram for a particular network, right? Where when you want to have a IoT based edge network. So you have the first block is the IoT sensors where regular sensors will be there. Then it will be connected to the edge device. It is IoT device with edge capabilities. Then it will be connected to the gateway. IS devices, right, will be retrieving the data from the IoT sensors, and it will be sending the data to the gateway. In turn, right, the gateway will be sending the data to the cloud. So these are the blocks, right, in a network diagram. So if you refer this A, right, the network flow, it can be in both modes. Wireless mode, you have BLE, Wi-Fi, Zigbee, or LoRaWAN. And in wired, you have SPI, I2C, and your or Ethernet mode will be the communication between these IoT sensors or the edge device. In case of B, right, the network flow between edge device and gateway, it's a wireless mode, normally Wi-Fi, LTE, 5G, and also you can have BLE also here. Haven't right? Even BLE also you can use here. I mean Bluetooth. Sorry, it's Bluetooth here. Yeah, then the C, right? The communication between gateway and cloud. It is the wireless mode only. This is a cellular mode. So here are the components, right? In this normal design, IoT sensors, which track the speed, position, track health. Then edge devices, you have the uh, process the data and send the gate to the gateway via this wireless protocols, even Zigbee, LoRaWAN, and Wi-Fi. Gateway is nothing but it will collect the data from the IoT edge devices and send it to the cloud. So cloud interface will be given. Then you have the cloud services. So here, right, in the cloud services, you can have the analysis of the data visualization and offer insights. So if you come to the architectural framework, right? So this is the complete block of a architectural framework. So first you have the sensor layer, data acquisition layer, then processing or control layer, communication layer, OS layer. So here, see in all these layers, right, from sensor to communication layer, right, most of it will be the hardware board, whatever you're using. The this part this part from sensor layer to communication layer, the hardware board, whatever hardware board you selected. So from OS layer and top, right, this is the actual application or the OS, right, whatever your your product, right. So that is there from OS layer to cloud interface layer. So in the buffer layer, basically your buffer management will be done here. And security, normally you will use for TLS or something else. Cloud interface is nothing but your AWS. So we'll go through each layer. So first one is the sensor layer. Sensor layer, which will have all these vibration sensors, GPS, accelerometers, temperature sensors, strain gauges, pressure sensors, and environment sensors. So here, right, you will be capturing the data, right, with respect to the sensor characteristics and convert into electrical signals and send it, because it's a analog device. Here then you have the data acquisition layer, so where whatever analog signal you get right in the devices, depending upon your use case, right, you'll be using this layer. Collect functions will be like it will collect the data and prepare for transmission or processing. So mostly, right, in this layer you'll have the sampling, filtering, and compressing of the data here, processing and control layer. S- So here you'll have your microprocessor or whatever processor you're using, right? All this will be there as part of this layer, your processor, or your particular boards, right? Specific information. So here, right, here hardware specific data processing, right? Initial data processing, including noise filtering, edge analytics, right? Data integration will be done here. Here, right, you'll decide which algorithm you can use and all internal to your. Then you have the communication layer, where you have LoRaWAN, NB-IoT. NB-IoT is also used, right, in communication. So these are the communication aspects, how we are sending the data. So yeah, it's more about connectivity from the edge device to the cloud or gateway. Right? Here, this will be decided. So all the hardware manufacturers, right, will give this support. So you have to appropriately use based on your use case. The OS layer is nothing but whatever firmware and the logics, right, will be done here. So you will be embedding. So whatever protocols, right, application protocols you have to use, like the MQTT, the RCOP, right, you can use here. So uh, and the storage layer. So how we are storing the layer and buffering mechanism. In case of edge devices, you'll have lot of data. So how we are managing the data and how we are sending the data, right? The buffer mechanism is here, and this part and the security layer. It's more with respect to how we are using the security keys and the firewalls and other aspects. And you have the last one is a cloud interface layer. So basically in the cloud interface, right, how you are sending the data with respect to the cloud, right, and the mechanism what you are using, so you can change according to the cloud environment. So here, so you can use for different cloud environments. So that's all for now.